Hey everybody, welcome back to CIS 17A. Today we are going to be covering lesson number 17, classes part 3, and we're also going to see how we can create a data structure, something referred to as a linked list. This is something that you will be doing a lot of in, I believe it's CIS 17C, data structures. So this is an example of a data structure, and we'll see how we can create that today. All right, lesson number 17. So you'll notice that this covers sort of a hodgepodge of different sections of the book. So we'll go through each one of these one by one. And the first thing it discusses is something called arrays of classes. So just like you can have an array of ints or floats or strings, you can also have an array of classes that you defined yourself. Now it says to start on page 759, but I'm not actually going to start on page 759. I'm going to start back here on page 754 because the first thing that is covered on page 759 is a discussion of the inventory class example that was given in the book. So let's do a quick review of this class definition for something called an inventory item. So an inventory item has three attributes that it is made up of. It has a string that is the description of that item. It has a cost, which is stored in a double. And then finally, it has the number of units that are on hand, and that's called units, and it's stored in an integer variable. So an inventory item has three different members. Now, this section of the book was talking about overloading constructors. So it talked about having a constructor initially that doesn't have an argument. So remember, a constructor that is not passed any arguments is called a default constructor. So our default constructor just initializes everything to nothing. So 0 for the cost, 0 units, and a string with nothing in it. Then it showed us that we can overload it and pass it just one thing. And if we pass it just one thing, the description of the item, that we're going to go ahead and then assign that value to description. And then we'll just initialize the other two attributes, cost and units, to 0. And then finally, we had a third overloaded constructor, which takes 3 arguments, the description, the cost, and the number of units. So in other words, it's going to initialize all 3 of the private attributes of the class. All right, so hopefully that's just a quick refresher on the inventory item. It was talking about overloading constructors. So let's go ahead and jump to the page that I listed on the website, page 759, and talk about arrays of objects. So, arrays of objects. You can have an array of integers, you can have an array of floats, you can have an array of anything. So you can have an array of classes that you defined yourself. The only thing we need to think about when we declare an array of objects is how we pass arguments to the constructors for that class. So let's go ahead and jump down here. So here, this is straightforward. We're just going to make a constant of 40 so that we can declare an array of inventory items of size 40. So let's think about those 3 different constructors. The default constructor, the constructor that was passed 1 argument, and then finally the one that was passed 3 arguments. So how would we initialize that array? So we know that we can declare an array and then not pass any value in here if we use the list notation, and then we provide, separated by parentheses, all the different parameters that we want to initialize over here. So in the case where the constructor is only passed 1 item, you can just do something like this. So you can just pass in as a string hammer. So again, going back, remember that the constructor for the inventory item class, if you only passed it one thing, that was the description of the item, and then it would automatically initialize the other 2 things to 0. So that's going to be what happens here. Moving down here, this is the same rule that we talked about earlier. If you do not have a default constructor, then you must provide an initializer for each thing. So we did provide a default constructor for the inventory item class so that we could actually do that. But if we didn't, then we would have to go back and make sure that when we did initialize it, that we actually passed it something. Otherwise, that would be a compile error. All right, so here's an example of calling the constructor, this is the third constructor. We're going to pass it 3 things. So remember, if you pass the constructor 3 things, it initializes all 3 attributes of the inventory item class. Now here's what's different. we're still using this empty bracket notation. We're still using the list notation to initialize the array of inventory items. However, notice that up here, all we did is pass it the description as a string. But down here, when we pass it three things, we have to actually call the constructor and separate that by commas. So you just need to know that for a quiz or an exam, that when you're passing the constructor just one thing, it doesn't have to be a string. It could be a string or a float or an int, but as long as you're just passing one thing, then you don't need to call the constructor. Anytime you pass more than one thing as you're initializing the array, you have to put in the name of the constructor and parentheses, and this is actually a function call. This is a function call to the constructor, passing it the required arguments to make it initialize itself correctly. All right. Okay. Let's see. And I think this just summarizes everything that I just said. If there's no default constructor, you must furnish an initializer for each object. So we've seen that before. If there are fewer initializers in the list than objects in the array, the default constructor gets called. So I didn't mention that. So in other words, if we said, like here's the example right here. So if we said this is of size 3, but we only actually provided two things to it, this and this, then that third and last item will be initialized using the default constructor. So obviously, if you're going to try to do something like this, you have to have a default constructor defined. Otherwise, that'll be a compile error. And then if a constructor requires more than one argument, the initializer takes the form of the constructor function call, and that's what I said earlier. Okay? All right, so that's how you can initialize an array of objects. Next, if you want to actually call a member function, you do it exactly the same way as you would do it with anything else. You use either the dot operator or the arrow operator if it's a pointer. So in this case, we are dereferencing element number 2 from the array. So remember, the array was called inventory. So we're accessing element number 2, and then we're going to use the dot operator just like we would as we've done all the way up to this point using classes and calling member functions. And then obviously set units is a function call, so you're going to have to put parentheses and then provide the value that it's looking for in that function call. So set units just is past the number of items in inventory, which in this case they're saying that it's 30 different things. Okay, here's an example of initializing an array of inventory items to 5 things. Looks like we're going to provide all this stuff to it, so there's no ambiguity. And then we're simply going to use a for loop to go through and print everything out using that dot notation, and then I to index our way through the array, just like we've seen a million times in the class. So starting at element number 0, while I is less than the number of items, which is defined up here, and then we just call those functions to print everything out. So all we're doing is inputting everything actually in the code, and then the code's simply just going to print everything out that was entered via the code. So now obviously that would not be how you do it in real life. You'd have CN statements grabbing all that information from the user. Okay, moving along, we are going to jump ahead to page number 799. So we're going to jump way ahead. Okay, to section or chapter 14, more about classes. All right, instance and static members. Now, up until this point, all the attributes of the class have been what are referred to as instance members. So when we had attributes like for the rectangle, we had the width and we had the length, what you were looking at was something called an instance variable or instance attribute or class member. You can also have what are called static members variables. All right. So in instance variables, as it says here, each class object gets its own copy of those member variables. So in other words, if we make 2 objects, box 1 and box 2, that are both rectangles, and then we set one to have a width of 5, length of 10, and then we set the other one to have 500 and 1,000, each one of those objects, box 1 and box 2, gets its own copy of width and length, which makes sense, right? Now sometimes, and they're just kind of pictorially showing you that here, now sometimes you actually want all the objects of the same class to share an attribute. And when you do that, that is what is called a static member. All right. So one way to think of this is that, as it says down here, static member variables don't belong to the objects. They actually belong to the class, and they're actually declared outside of the class at global scope, as we'll see down here in just a moment. And to go one step further, you don't even have to actually declare an instance of that class for someone to be able to access that static variable. And we'll see why that might be useful down here in this example called tree. All right, so here's the big difference. We have a private data, and this is an integer object, and we are putting the keyword static in front of the type of the object. And that's going to make it a static member variable. So how do we initialize that? You're actually going to just go outside of the class. So remember, the class definition goes from here to the semicolon. And then outside of the class, you're going to do this. You're going to put the type for the static variable, followed by the name of the class that it belongs to using the resolution operators. And then here is where you will initialize it with some value. And this is why you can access these even if you don't declare an instance of the class. So it might be useful to just know how many instances of this tree object have been created, and we might need to do that before one is actually ever created and know that there are none of them. All right, so that's by the way a very common use of static member variables in classes, is to just keep track of a count of how many instances have been created. So how do we keep track of that once we start adding stuff? We just do that in the constructor. So in our constructor, we're just going to increase the object count by 1 every time something is created. And then we could go one step further, and if we were dynamically allocating stuff in the destructor for the tree, we could decrease the count by 1 so that we can keep track of how many things. They just didn't show that here. Okay, and then we have a member function that we can use to return that value called getObjectCount. All right. So then if we just scroll down a little bit, this is just telling you what I just told you a second ago. So if we scroll down here just a little bit, here's an example of actually using one in your code. We declare 3 instances of a tree object, and then down here to get that static value, we call the getObjectCount from the pine instance. And then I think right down here they're going to tell you we could have done this with any of these objects to get that value, and of course because it's shared amongst all of them we would get the same result, and I think that's what the example they show right down here. So you can see oak, elm, and pine all sharing that static variable. And then down here, yeah, they're just saying that any one of these objects, oak, elm, or pine, if you call that, would give you the same result of 3 whenever you call for any of those. In this next example, it's pretty lengthy, so I'm going to go through it as quickly as I can. Here's another example of how you could use a static member function, static member variable. All right, so in this idea, this class represents a budget, and it represents a budget for some corporation, and that corporation is made up of 4 divisions. So we are going to have each individual division's budget, and then we're going to have the corporate budget, which is the sum of all of its divisions. So yeah, let's go and move on down and just check it out. All right, so our default constructor is going to just set the division budget equal to 0. And then because the corporate budget was static, we're going to initialize that to 0. Again, just like we saw above, outside of the class declaration. Notice here's the big difference, is that anytime we go to add to the budget of any division, we also have to add that amount to the division of the corporate budget. All right, so you're going to not only add to your division's budget, you also add that same amount to the corporate. Down here, we're going to declare an array of budgets called divisions. So again, we have 4 divisions. We're going to use a for loop to gather all the information. So we're just going to cin the budget amount and then immediately call the add budget function and pass it in that amount that the user provided. And then just like with other for loops, we're using count as the iterator. Or the index variable. All right, so and then going back to the declaration above, we know that this amount is going to get added to not only that divisions, but also to the corporate budget amount. All right, and then lastly, we're just going to print out all the values. So it's going to look something like this. We're just gathering information for each separate division, and then behind the scenes, using the static attribute, we are going to sum all those up. So the sum of all of these equals to this amount right here via the static variable. All right, next we're going to move on to page 812. Member-wise assignment. So member-wise assignment is just going to show us that we can use the assignment operator to assign all of the attributes of one object to the attributes of another object. And that's basically it. So it does a one-by-one assignment for each of those separate values. So here in the example, box 1 is a rectangle object that has a width and a length, and we're just initializing that to 1010. This one we're initializing to 2020. Here we're just printing out, hey look, it's 1010, it's 2020, and then here's where you're using the member-wise assignment, using the assignment operator. We're going to assign all the attributes values of box 1 to all of the attributes values of box 2, so that the next time that we print everything out, they should both be the same. And that's what we get here. So this is before we use the member-wise assignment, and this is after we use the member-wise assignment. We can see that it's copied the values of box 1 over to the attributes of box 2. All right. The next thing it's showing you is that you can also just use an assignment statement like this. So you can load up box 1 with some values, and then when you declare the instance of box 2, use the assignment operator, just like we've seen done with integers and floats and everything else, right? So if we say int x is equal to 1, we then can later say int, I don't know, num2 is equal to, I can't even remember what I said the name of that variable was. But anyways, yeah, that's the the same thing we've been doing in the class up to this point. So nothing too fancy going on with the member-wise assignment. Okay, we're going to jump ahead yet again. So we're going to go to 819. I know I'm not showing examples of these things in the compiler because I feel that they're pretty straightforward, right? So hopefully you guys don't feel the need. But again, you guys should have your compiler open and running while you watch these videos and kind of play around and test some of these things out as I go along. Okay, operator overloading. So operator overloading is a fancy feature of C++. So operators are things that we've seen all over the place up to this point, like the plus equal operator, or the plus plus operator, or the minus minus operator, or the assignment operator. So all those built-in, or or division, addition, subtraction, multiplication. Those are all examples of operators. And what is fancy about C++ is that you can redefine how the standard operators work when you're using your own class that you created. So when you're using things like integers or floats or doubles or chars, all the built-in data types for C++, the behavior of all those operators is already predefined for you. And it does mention down here that it actually already does some kind of fancy stuff like with division. So remember that when you use the division operator, that's that little symbol right there, that if you pass it to floating point numbers, it will do floating point arithmetic, whereas if you pass whereas if any of them is an integer, it will do integer division and throw away the decimal part of the result. All right, so that's an example of overloading, right? So depending on the type of the things that are passed to the division operator, it will do one thing or it'll do another thing. So the same is true with classes, is you can make it so that depending on what classes you provide to the operator, you can write your own custom code or overload the code that is already there for the operator so that it will do what you want it to do. Now, it's worth noting that if you don't overload the operator and you just pass it some classes, that's a compile error. It will not know what to do because you haven't defined what it should do with those class types when you use that type of operator on them. All right, so let's go ahead and see how we can do that. Okay, so here they're just showing you that this is a member-wise function. Like we saw before. So that's the only one that's already built in for you is the assignment operator. That's the only one you get for free. Like I said, anything else you have to provide code for it. So the way that you do that is by providing it, let's see, is it down here? Yeah, way down here at the bottom, is you use the keyword operator followed by the symbol of the operator that you're trying to overload. So you could put operator equal, operator plus, operator plus plus, operator minus minus, and there's only a few operators that can't be overloaded in C++. Now you don't have to actually go through this entire example. You can see this is actually a really big class. You don't need to go through this entire class to understand how to write or how to overload an operator. So what does this represent? This is a class that represents student test scores. It has the name of the student. They're using a pointer to a double, which is actually going to not be a single value. It's going to be an array. So remember, you can always use pointers to something to represent that base address, or not base address, but the memory address of element number 0 in the array. So that's what they're doing here, is that this is actually an array. It's not just a pointer to a double, just like we've seen in other examples. And then the total number of test scores that are in that. So this is the number of things that are in that array, and we can use that in our for loops and whatnot down here. So I'm going to go ahead and skip some of this and just go to the operator overloading part of it. All right, so what do we got? So first off, we are passing in a student test scores object to the class, or to the operator. So that's what this class is, right? This is a class of student test scores. So because again, we're going to use the assignment operator here to copy one student test scores object over into the other student test scores object. Now the reason that this has to be a little bit more complicated when we do assignment is because in member-wise assignment, remember, it just goes one by one, copying each individual attribute over into the other attributes in the thing that it's being copied into. So the assumption there is that the data types are all very simple, right? Like string, double, int, but not an array of things, that they're all just single instances of those objects. So because this is an array, we have to be a little bit more careful about how we copy everything over into the other object. So for example, down here, we are going to have to delete whatever it is currently pointing to. So remember, to delete an array, you say delete, and then you put the square braces followed by the name of the array. All right, next, it's going to take the value of the thing that is being passed into it. So this is the name that we're using here just in the member function, and we call it right because you can think of it as being the thing that is to the right of the operator that is being copied into the thing to the left of the operator. So here, once we've deleted the test scores, we can just do one by one for these because these are not arrays. So student name is just a single string. So we're just taking the value of right dot student name and assigning it to our value. And then same thing here. We're just taking the value of num test scores and assigning it to our value of num scores. Okay, now when it comes to the test scores, because that was just a pointer to a, what was that, a pointer to a double, now we have to actually dynamically allocate that array like we've seen done in the past. So we're going to say new, the type, and then the number of things to copy over. And then we're going to use a for loop to one by one copy each of the test scores from the thing on the right to the thing on the left. Okay, so that's why we have to do things different, is because it wasn't just, again, it wasn't just a single value. If everything was like this, we wouldn't have to overload the operator. We could just use the default built-in member-wise copy function that is built into the assignment operator with classes. But because it's an array, we have to handle it differently. Okay. All right. So down here, so this is what's finally happening, right? So we have student number 2, and we want to copy everything from the instance of student number 1 over into the instance of student number 2 using our overloaded operator down here that we've been staring at. Okay. Also notice this as well. This is something you've heard me talk about again and again, is that when you're passing an object to a function, or if you're passing anything that has lots of data in it, like an object, you always want to pass it as a constant reference to the object. You don't want to just pass it in as a student test score by itself without the reference symbol and without const, because then it would do a one-by-one copy of all that stuff up into this temporary value before it tried to move everything over. And so this is just for efficiency reasons. Whenever we pass objects to functions, we do it as a constant reference or as a pointer to the object so that we don't get that overhead of the copy. All right, so that's the mention right here. This is for efficiency purposes. Okay. And then here they're just saying again that the reason that they name it right is because it's the thing that's on the right side of the assignment statement. Okay, now there's actually a lot more complex things. Oh, and then yeah, this is the last thing I'll mention about it. All right, so this right here is the equivalent of doing this right here. So because that operator equal is a member function of the class, you could call it using the dot notation that you use for calling any member function of a class. And these two things are equivalent. So because we overloaded it, we could just do this. It looks nice and clean, but if we wanted to, you could also do this as well, explicitly calling it using the dot operator. Those are the equivalent statements. So that's really all for operator overloading. So yeah, you can do a lot more fancy stuff with operator overloading. So just doing a simple assignment statement, that's like the simplest form of overloading an operator for a class. But you can also do other stuff like say this is a class A and say that this was plus. You could say that class A is equal to class B plus class C, in which case you would have to do something a little more fancy using the return this. And I didn't include this in the reading, and I'm not going to cover this because it's a little bit more of an advanced topic that you would get in like CIS 17B. For example, so you don't need to know about it, but you should know that that there's more to operator overloading than just what is shown in that example above, and that gets into the this statement and returning a constant instance of that class. But again, don't memorize any of that. You don't need to know it. Okay, moving along to page 849. All right, and this is the last thing that I'll show you in the reading, and then we'll get to the linked list assignment. So aggregation. Aggregation is simply when a class contains an instance of another class. You've actually already seen that a class can have as its private attributes other classes. So here's an example where we're going to have a class which has a course name. It has an instructor's first, last name, and their office number, and then it's going to have the textbook's title, author, and publisher. And what it's pointing out is that rather than having this as 1, 2, 3, 4, 5, 6, 7 different private attributes, it would probably make more sense to aggregate this information into its own class. So instead of having, what did I say, 7 or 8 or whatever private attributes, you would just have 3. You would have course name, instructor, and textbook, and you would aggregate into this instructor class all of this information, and then in this class you would aggregate into it all of this information. All right, so let's see how we could do that. All right, let's first define the class for the instructor and then the class for the textbook. So remember the class for the course is going to have the course name, the information about the instructor, information about the book. So let's start by breaking down the instructor one. So it's going to have, as we saw earlier, it's going to have the first name, the last name, and the office number of the instructor. Nothing fancy going on there, just 3 strings. And then we got a default constructor, which just initializes everything to an empty string. And then here's what's different. In the constructor where we actually are passed 3 different objects, we don't do it directly, we do it indirectly by calling a member function called set. Okay, now we need to do this because from the class, the course object, we're going to need to be able to call the function to set those values. So we'll see that in just a second. But for now, let's just see that this is the thing that's different. So in the constructor, we're calling our own function, our own member function. So note that because we're in the class, we don't need to use the dot operator to call that function. So it's going to go ahead and call set, and it's just going to basically copy everything down. So this is going to get copied in, and then copied over to here, and then get copied over to here, and then finally initialize the last name here. So there's a lot of passing the data around, notice, in that process. Now there is actually much more elegant ways to do this, but it involves pointers and things like that, which are a little bit more advanced than the scope of this class. But for now, we'll just see how they do it here. All right, so same thing, first name gets passed into here, which gets passed into here, which gets passed down to here, and then finally assigned to first name here. Okay, so we're calling a set function to initialize these values up here. And then we'll see that for the, what is this, the instructor, we'll see that for the textbook, it does the exact same thing, right? It calls its own set function in order to initialize all of its private members up here. Okay, why do we need to do that? Like I said, finally, when we have our course only has three things. It has the course name, which is just a string, and then this is the aggregation part. And this is also, by the way, called class composition, when you have a class that has other classes in it. So this course class has an instance of an instructor class in it and the textbook class that we just saw above a moment ago. Now here's the crazy part, is that we need all that information passed to the constructor. So if you look at the constructor, it is huge. We're passing it all the information that it would need to initialize not only the string here, but all the information here. And that's why we had to use that set and member function. So this is straightforward. We just give the course the name, but then we use all this other data here to call the set function for both the instructor, and then the exact same thing to call the set function for the textbook. All right, so in the other ones, they did have their own little constructor that you could pass it through things, because you could use these outside of this class, right? So it may be that we're going to use this class in other things, or even standalone by themselves, we could use them. So that's why they still have a constructor in the class that can either like initialize it to nothing or initialize it using the set function. Okay, but that's it. That's how you would use class aggregation. And then it just notes that this is what is called a has a relationship versus what's later we'll see is called an is a relationship. So whenever we say that something has something else, like for example, a course has an instructor and a course also has a textbook, that's just a has as relationship versus something called an is a relationship, which we'll see when we talk about inheritance in the next lesson, right? So, all right, and that's it for the reading, okay? And again, I didn't want to bother going through examples of all of these. You just need to know this stuff for quiz or an exam. All right. Okay, and let's see. Yeah, here they are giving the example, and you can see, look at the constructors. The constructor is just filled with all that data that it gets passed over into the course function. Okay, hopefully that's not too confusing, you guys. The next thing we're going to cover is how to create a linked list. All right, so this is a pretty ambitious lab assignment, but I'm going to try to give you guys lots and lots of help here in the last half of this video. Okay, so let's start off just with what a linked list even is. And by the way, we're going to create something really specific called a singly linked list. There's also something called a doubly linked list. Now, the way you want to think, and I know the text is kind of small, but you want to think of a linked list as a data structure similar to something like a vector, in that a linked list is, and a linked list is also similar to an array, in that it's going to have several different elements that make up the whole of the linked list. Now, the way that it's similar to a vector is that unlike an array, a vector can grow and shrink. You can declare an empty vector and then use the pushback function to add stuff to a vector. With a linked list, you can not only do that, but you can actually just write as many custom member functions for the linked list as you want. So you could make a linked list that can, for example, find the maximum value or the minimum value, or return the size of it like a vector, or find the average value, or print everything out. So with linked list as a data structure, you just have a lot of flexibility as a programmer as far as what you can want to do. In fact, you have infinite flexibility virtually, because you write all the code that determines what it does. All right. Whereas an array or a vector is made up of elements, a linked list is made up of something which are called nodes, and each node is connected to other nodes in the linked list, and each node will contain a value. and that value can be whatever you want it to be. It could be an integer, it could be a float, it could be a string, it could be a class, or I should say it could be an object. It could be whatever you want it to be. All right? Okay, now for this lab, you're going to have to create two different classes. You're going to have to create one class that represents a node, and then you're going to have to make a separate class which represents the linked list. But let's go ahead and just do a little quick demonstration here using Paint to see kind of visually like what is going on with a linked list. So think of a linked list as, like I said, a collection of nodes. So the square is a node, and a node is going to have two different values, or two different private attributes in it. So this is a node. It's going to have internally some value that is based on whatever the type of object it is. If it's an integer, it's going to be an integer. If it's a I don't know, if it's a rectangle, it's going to have a rectangle that has a width and a length, right? So that value is just whatever is being stored inside of the node. And then it has this little pointer, and that is going to be a pointer to another node. Okay? So that's what a node is. It's just something that contains a value and that also has a pointer to another node. So in a linked list, you actually just have a whole series of these little guys that are connected to each other. Oops. That are all connected to each other like so. Okay, so you'd have another one that comes right after that one. And then you'd have another one that comes right after that one, and so on and so forth, until finally you're going to get to a node at the very end that is going to have a pointer just like all the other ones, except for instead of pointing to another node, that node is going to point to the value null. And that is how we know that you're at the end of the list. All right, hopefully that's big enough you guys can see it. Let me bump that. Oh, wow, that's way too big. All right, hopefully that's big enough you guys can see it. All right, so yeah, so that's what. So notice the how this sort of visually looks kind of like an array, right? So an array has element 0, element 1, element 2, element 3, whereas a linked list has a collection of nodes. The other difference to notice here is that arrays don't have these pointers, right? So in an array, you're just declaring a block of memory, right? And there's no functions or anything associated with the array. You're responsible for managing how that array is dealt with. Whereas with a linked list, we can build in functionality. Now there is one other special node that is at the very start of the list, and that is usually referred to as the head. So let's copy this one down here. Okay, and just move these guys over a little bit. And hopefully that's not cut off. Looks like it is. Yeah, it got cut off. So we'll just make a copy of this guy right here. And you guys don't need to obviously do anything. I'm just doing this as a demonstration so you guys can visually kind of understand what the heck a linked list even is. So that's the first node in the list is the linked list is a special node referred to as the head. All right. So there we go. So this collectively is sort of what you want to think of when you're thinking of a linked list. A node that is at the head or the start of the list, and then pointers to all the other nodes, and you can have as many nodes as your memory allows you to have before it runs out. And then finally, the last pointer of the last node doesn't point to another node. We make it point to null to represent the end of the list. All right, so hopefully this little visual demonstration helps you guys kind of conceptually understand what a linked list is. Now for today's lab, we're only going to make a linked list that does two things. It is going to allow the user to insert a value into the linked list, and is going to allow the user to print out the contents of the linked list. And it's worth noting that whenever we do insert a new node into the list, we're always going to insert it at the head of the list. Okay? Now I have, actually I'll just hold off on that. All right, so let's go ahead and get into the node class first because that's the easiest thing to define. Now notice that I mentioned you can define this entire class in line. It's that simple. So for all the private members, the value and the next pointer, we can handle all that stuff all in the header file. So normally you'd split everything up between the header file and the source file, the .cpp file, but in this case we're just going to put it all in the specification or the header file. Okay, and we're going to need to have 4 member functions for the node. It's going to have a constructor. It's going to have a member function called getNext, which retrieves the memory address of the next of whatever it's pointing to and returns it. And then a member function called getValue, which returns the value of the thing that is being stored. To keep things simple, our linked list today is just going to store integer values, and that's it. And then finally, a member function called setNext, which simply allows the user to pass it a value and then assign the thing that it is pointing to, assign that node to whatever it is pointing to next. Okay? All right, so a constructor, getNext, getValue, and setNext, which will set. So if we go back to the picture, so setNext will make it so that we can set whatever this is pointing to next. Let me move this over. Maybe it'll be more helpful if we look at this. So getValue, which just returns this value in here. GetNext, which returns what this is pointing to. So that'll return the memory address of the thing that we are pointing to. And then the constructor, which just initializes the value and then initializes the pointer to null for temporarily. Okay, so let's go ahead and code all that up. All right, I've already done a lot of coding in here to speed up the video. So main.cpp, just the regular stuff in here. The only thing new is that I'm going to have to include my linked list class. So let's look at our linked list header file. Okay, so same thing, we're going to put our include guards, and then we're going to have to include the header file for node because we're using aggregation here, like we saw just a moment ago. So we are going to, inside of our linked list class, have an instance of a pointer to a node. Okay, and that's going to be that pointer is going to be the pointer to the head of the linked list. Okay, all right, let's go ahead and move over to node.h. Same thing. Here we don't have to include anything. Actually, we do have to include something. You have to include IOStream, and you have to put using namespace std because we're going to initialize the node's next pointer to null. In order for us to use null, we have to include std from IOStream to do that. Okay, and then finally, separately in a linked list.cpp file, why are we getting error messages? I'll come back and look at that in just a second. We're going to have, these are going to be the definitions for all the member functions that we're going to eventually, because we haven't put them in here yet. Okay, and these are going to be the member functions definitions in the CPP file. Okay, let's start off with the node. Actually, let's start off with main. So main's actually going to be incredibly simple. This main program is just going to drive or test out that the member functions in our linked list class actually work. So this is going to be incredibly simple, but this is actually going to be the last thing that we code. All right, let's go back over to the example. Let me see if I can make this bigger so you guys can see it. Okay, that's better. Okay, so let's go in here. So we're going to actually start here at the bottom with the node class. Like I said, it's the easiest thing to define. All right, so private attributes. We need an integer variable that we're going to call num and a pointer to a node called next. Okay, so that's going to be, again, the value and the pointer to the thing called next. Okay, so let's go ahead and code that up. Okay, node.h. Okay, so these are going to be private. So we're going to have an integer that represents the value, and we're going to have a node pointer to the next thing in the array. Now here's something kind of interesting. Here we're actually declaring an instance of the class inside of the class. And the only reason we can get away with doing that is because it's a pointer. It's not an actual instance of a node. If I tried to make this an actual instance of a node, that would be an error, right? Because we can't, I'm surprised it's not giving the squiggly line. All right, the reason we can't do that is because we haven't defined the node. So we're going to make it a pointer to a node, not an actual instance of a node. Because remember, a pointer is just a memory address. So we're just saying that this is the memory address of another one of me, right? I'm pointing to another instance of me. Okay, so that's all there is to these first two things here. Next, in the constructor, we're going to pass it an int that we use to initialize the value and then set the next pointer to null. All right, so we're going to make this constructor node. And like I said, we're going to make everything in line. So it's going to get an integer that is the value that we want to initialize. And then we're going to make this in line. And we're just going to say, actually, instead of calling it val, let's call it num, so that it's not the same as val. We're just going to say num is equal to val. And we're going to say that next is equal to null. Like so. And semicolon. All right, so again, we're just making it inline so that we don't need to have another constructor, another source file. All right, next, get next just returns whatever next is pointing at. So it's an easy one to do inline. So get next returns a pointer to a node. So node star, it's returning a pointer. And then, what is this called? Get next. Okay, and we just simply inline this and say return the value of next. That's it. It's that simple. Get val is going to return an integer that represents whatever is being stored here in val. So that's an int that we're returning. So get val. Again, we'll inline it since these are all just one lines of code. And then last but not least, set next, which is going to get a pointer to a node and assign next to that node. So it returns nothing because it's a set function. And I guess we could make these constant, but because node is actually never going to be used outside of the linked list, we can just go ahead and cheat. Did I tell you guys to make them constant? Nah, I didn't tell you to make them constant. Well, even if I set it up there, it's okay. Just to keep things simple, don't worry about making them constant. Because they're just returning values and not modifying anything, they should be constant. Okay, let's just go back to here. So this is set next. Again, we'll make it in line. And this is just going to, there's got to pass in a node, a pointer to a node called n. And then we'll just say this makes next equal to n. And that's it. So that's an incredibly simple class, right? Doesn't really worry about protecting the data or anything like that. It's just going to set stuff. And again, this is not really more about protecting classes or anything like that. This is more about showing you guys how to make a data structure called a singly linked list. Okay, so hopefully that helps you out for creating that node class. Okay, next let's move up and let's go ahead and, this is going to be more complicated. Let's go ahead and create our linked list class. Okay, private attributes, it's just going to have one, a pointer to a node called head. And that's it. Okay, so this is going to be a pointer to a node called head. Member functions, we got 4. Let's start off the constructor. All the constructor does is set the head to null. And we can make this inline since it's one line of code and not put it over here in the CPP file. So here's our constructor. Say node, not node, say linked list. And then we're going to inline this one because all it does is set head to null. So when we create a new instance of a linked list, it doesn't point, the head doesn't point to anything because it's empty. Okay, next let's go ahead and define our destructor. So our destructor will delete all of the nodes that are inside of the list. It'll go through and it will just knock these guys out one at a time using delete. Okay, now we're not going to inline this though. We're not going to inline this. We're going to actually put this over in the implementation file. So remember, we got to put the tilde. If I can see, where is the tilde? Over here. All right, and this is going to be for our linked list destructor. Okay. All right, remember that the destructor does not return any values, nor does a destructor ever get past a value. So that's all we got to put for the destructor. Okay. Next, I have our insert function that allows us to add values to the linked list. So this is going to get It's going to return nothing, and it's going to get passed an integer that represents the value we're adding to the linked list. So you can actually just copy and paste this right on over here, like so. And then finally, a print function, which will print out each value contained in each node in the linked list. So again, you can just copy this over here. And here I actually did use a constant, make it a constant function because it's not modifying it. All right, and that's it. That is your header file for your linked list. Okay, next we got to do all of our implementations over here, or create all of our definitions for all of our functions. Okay, what order do we want to do this in? Let's go ahead and do the print function first. Okay, so how are we going to print out the contents of the list? Well, what we can do is we can create a pointer to a node called temp. And we can initialize temp to, for the first run, whatever the value of the head is. So when we initially start up the printing, we start off by saying that temp is equal to head. All right. So we're going to make a pointer to a node called temp and initialize it to whatever the current value of the head is of the linked list. Okay, so that's how we do that. Next, we can go ahead and print out. Well, actually, let's go back over to the picture. Okay, so next we're going to need to go through each one, and what we can do is we can just use a while loop. We can say while the temp pointer is not equal to null, call the getValue function of the node to print out the value to the screen. So I'll say that one more time. We can say while this temp node pointer is not equal to null, call the getValue function for the node. So let's see that. So while temp is not equal to null, call, you gotta use arrow notation because it's a pointer, call the getValue function to get the value, and then we're going to be printing this out to the screen, so we'll have to see this out. Okay, and then we'll put a space between each thing, like so. All right. So remember, getVal, if we go back over to the node, getVal just returns the value of the node. Okay. This one. Okay. Next, we need to increase, or not increase, but we need to move temp to the next node. So how do we do that? To do that, we are going to use the get, oh, I misspelled next. We're going to call the getNext member function, which returns whatever the node is pointing to next. So we're going to make temp now equal to whatever this is pointing to, which happens to be this guy. So temp is equal to get next. Actually, I'm sorry. Temp is equal to whatever temp is it points to next to is, like so. Okay, so that line of code is going to advance from one node to the next. So temp is equal to whatever that node is pointing to next. All right, so what's going to happen? So eventually it's going to get to here. I wish I could fit this all on one screen. I can't. I'm getting little weird errors too. Can I do it? Yes, I can do it. Okay, so while temp is not equal to null, so temp is going to go to here, then it's going to go to here, then it's going to go to here, then it's going to go to here, and then it's going to go to here, which we know is equal to null. So temp is equal to temp is temp is equal to temp get next. Okay, so hopefully that makes sense how that works. And then finally down here, we'll just print out an inline. Okay, and that's it. That's all you got to do to print out the contents. Now, the process of deleting the linked list is very similar. So we'll go ahead and just copy this code right here. We're going to do the same idea. We're going to have a temporary node that is equal to the head. And then we're going to say, while we're not pointing at null, we want to delete. But we got to be careful how we do this. Because remember, if you call delete on null, you'll get a syntax error. Not a syntax error. You'll get a runtime error. It'll crash your program. So in order to make sure we don't do that, we're actually going to declare another node pointer called del for delete. And we're going to set that equal to temp, because we know it's not null, because if we did this line up here. So while temp is not equal to null, let's create a temporary pointer here that we can delete safely. Then let's go ahead and advance the pointer by saying temp is equal to temp, whatever it points to, using get next, like so. Okay, now it is safe to delete del. Okay, so just to run through this. So we know that because we got into the loop that that's not equal to null. So we set up what we want to delete. We advance temp, which is eventually going to make us get to null. And then we delete the node that we know is safe to delete. All right, so that's just going to work its way through and systematically wipe out one node at a time so that we don't have any memory leaks once the linked list is no longer used anymore. All right, so that's it. That's all you got to do for your delete function. The last one is a little trickier, which is the insert function. So how do we do the insert function? So with the insert function, let's go ahead and start off by just kind of looking at what the situation is going to be from the start to the end. So let's go ahead and just delete everything inside here, because this is going to be what we have initially. Okay. So when we start off, actually we're going to have even less than, let's just delete the whole darn thing. Okay, so initially we have an empty linked list. So we have a pointer to a node called head, which is pointing to nothing. So this is what the linked list looks like initially. We have, I did put, I'll just do that. All right. So this is what our linked list looks like before anything has been added to it. We have a pointer to null. And that's it. Head is a pointer to null. Okay, when we want to insert something, what is the basic process? First, we're going to dynamically create a new node. The constructor for that node is going to make it point to null as well. And it is going to initialize it with some value. Okay. So that's what happens in the constructor for the node. Okay, so in order to insert this into the head of the linked list, we're going to have to first make this pointer point to the head to make it the front. Okay, and then we're going to have to give this some temporary name like temp. Okay, so this is what it's going to look like initially. We create a new instance of a node called temp, and then we pass it the value via the constructor. All right, so this is what it's going to look like when the list is empty and we're trying to insert something. We initially have a head pointing to null. We declare a new instance of a temporary node. Next, we have to make this guy down here point to the head. All right, in this case, the head is pointing to null. So it's actually not going to do anything. Well, it is going to do something. It's just a little redundant. It's just going to make this point to whatever head's pointing to, which is null. Okay, next what we need to do is we need to say that the head is now equal to the temp. Okay, so we need to make head now equal to temp. All right, so it will now, after we insert the first thing, internally look like this. Okay, so that's when we do our first insertion. Now, it turns out for every other thing that we add to the list, as long as we're inserting it at the head of the list, we just do the exact same thing. So let's look at inserting another node. All right, so we know that we're going to create a new node called temp, and that's going to get initialized to null. Okay. And it's going to initialize the value. And remember, the nodes constructor is doing that for us. And it's going to initialize that to null. Okay. Next, we make it this point to the head. In this case, the head points to this node over here. So now this is going to point over here. And this is going to be, not a big arrow. This is going to be gone. So that's now pointing to the other node. Okay. So it's going to be like that. And then we just say that head is equal to temp. So head is equal to temp, and then we're done. Okay. So notice that was the exact same steps, and we could do this over and over and over, and it's just going to be the same thing over and over and over. All right, so let's go ahead and just take a look at that in code. And yes, I gave you guys all the code for this assignment. That's your reward for watching these videos. All right, so let's do it. So we're going to make a node star called temp is equal to, and we're going to have to dynamically allocate this using new, and then call the constructor for node. And what do we pass it? This guy right there, val. No. Yes. Okay. All right. So let's just jump over here real quick. So we know that it's going to call the constructor, which is very simple. Like I showed you in the video, it initializes the value. It makes the next thing point to null. All right. What do we do next? Next, we are going to say that temp, we need to set what we're pointing to next, and we make it point to the head. That's it. So notice that with the first thing that we insert, that's going to set, because head is equal to null, so for the first thing that we insert, it's going to automatically make that last thing point to null, which is what we want, right? We want it to point to null. Okay, and then finally, we make the head equal to this temporary node. That's it. That's all you got to do. All right, so there you go. That is all the code to implement a singly linked list. All right, let's go ahead and just test everything out. Let's go ahead and just compile and see if we got everything right. And looks like we're good. Okay, so it's a program that doesn't do anything because we haven't done anything in main yet. So let's do it. Let's go ahead and make an instance of our new fancy linked list. So linked list L. Okay. Now we can go ahead and fill it up by calling the insert function that we just wrote. L dot insert, not head, L dot insert. And we pass it some value. We'll do that. I'm going to hold off on that because I want to copy and paste this a few times. Okay, so let's pass it an integer. Let's pass it 2 and then pass it 5 and just making up numbers. These don't matter. Okay. And then let's go ahead and print out the value of our linked list by calling the print function like so. So we're going to insert 2, 5, 7, 9. 9 by the time we're done will be the head of the list, So it should print out 9752. Let's see if we did it right. And it didn't work. Okay, let's go ahead and see what I did wrong here. I see what I did wrong. These are flipped around backwards. So num is the thing that the user provided, and here I'm saying that num is equal to val, and then val is uninitialized, it's just garbage, so that's why it printed garbage out to the screen. So we want to switch those around. Val is equal to num. Let's try that again. All right, so inserting 2579, it should print out those numbers backwards. And there we go. All right, so there you can see how to create a singly linked list. And again, note that it's very similar to an array or a vector. Because we're using new to dynamically allocate each node as we insert it, we can do this, like I said earlier, as many times as we want until we run out of memory. All right, you guys, so just like as before, when you go to turn in this assignment, you're going to go ahead and zip all these. You're going to have to download these and zip them up and submit a zip file that contains all these files to get full credit for it. All right, but I thought it would be nice to just give you guys a lab where I showed you everything, especially with something as complicated as a data structure. If I was doing this face-to-face, I would expect you guys to do a lot more, but it's really hard to even understand the concept of a linked list. So, all right, good luck with that, you guys. As usual, if you have any questions, don't hesitate to send me an email, and I will see you back here soon for our last two lessons.